Module 3, Processes. So, what we would look in this module is, first of all, we will understand what is meant by an process in a computer. So let's look at the basic definition. When a program is being executed, like let's say a file has to be stored in the computer. So this is a program which needs to be executed. This, in terms of computer language, is known as a process. So when we are dealing with the computers, whenever something has to be done, let's say we click the photo. So when we are clicking it, it is a process. When we open an app, it is a process. When we delete a file, it is a process. So everything which happens inside a computer is actually a process. So lots of processes are being done on a computer simultaneously. Okay. So there is a little more bit of a theory, if you want to understand that, would be provided with the notes. But the basic understanding you need to have is that whatever is happening on a computer or a mobile phone device is actually a process. Okay. So let's see how a process is actually executed. So for that, we have to understand that if any process has to be executed, that would be executed on a microprocessor. Micro means small and processor means the hardware on which the process runs. Okay. In general terms, we also call it a CPU or central processing unit. Initially, with the CPUs which were made was single core. That means they had just one core. One core means at a time we can execute only one process. Now with advancement in technology, we have CPUs which are dual core or quad core, which means that simultaneously we can run 2 or 4 or more programs. So more cores means more programs could be run simultaneously, so that the computer can do multitasking. Okay. So in today's time, you will not find a device with less than 2 CPU cores at all. Okay. So the basic thing is, you can understand it like as a window. When we go to a box office and we have to book tickets, let's say, for the movie. So if we have only one box office, then only one person would be able to get a ticket at a time. If we have two box offices, then there would be two queues, and simultaneously two people can buy tickets. Okay. Now some people take a lot of time choosing which movie they want to watch. So there could be processes which take long time to execute, and there are processes which take less time to execute. So someone who has already decided which movie they want to watch, which row they want to sit in, how many tickets they want, they will quickly do it. But some people will take longer time. So that is how there are small processes, there are long processes. Okay. So just think of it like we have a box office and we have people coming in queues. So processes are also kept in queues, like people are standing outside the box office, and we keep on selling tickets. So each process keeps on getting executed and new process keeps on coming. Okay. Let's move on. Now I have explained a basic architecture of a CPU. Now how it happens is, like, there would be an input device, like I typed something on the keyboard. So those instruction, like I press the space key. So the space key instruction will get inside. Okay. um, Now the CPU can read from the memory, and it can give instructions to the memory again back. Okay. So let's say I press the space bar, so that instruction got into the through the memory into the central processing unit, and then it checked what the instruction is. Okay, it is a space bar, so it will give a command to give a space in the words. Okay. Then that would be executed, and on the output device, let's say your monitor, that would be executed. Another example we can take is like I am opening a file, so I'm double clicking on the computer. So when I double click, uh, uh, that instruction would get inside the CPU, and then CPU will say, okay, we need to locate this file. Then it will start searching for that file. Okay, so there would be a map of all the files, like we have index in a dictionary. It will search whenever it finds a file, it will open that file, um, and then it would be shown on the output device. Okay, so now how does memory come into picture here? So if any instruction set is there, it would be written in the memory, because CPU cannot handle a lot of information at a time. It just takes the information which is necessary at the time, and rest all important information which might be required later on are written in the memory. So let's say if a very big program is there, we are supposed to run it. Let's say I have to open the Photoshop app, or let's say Chrome browser. That's a easier example. So if I have to open the Chrome browser, that Chrome browser would be loaded in the memory. Okay, so any instruction I will give on the computer to, like if I'm scrolling my mouse on a web page, okay, those instructions would be taken from the input device into the CPU, and then it would be executed and would be given out on the output device. But where is all the data and information of the Chrome stored? That would be stored in the memory unit. When I close the Chrome browser, this would be removed from the memory unit. Why? Because we have limited memory. Generally in our computers we have 8 GB or 16 GB of memory, and we do not want to fill it. If anything extra needs to be stored, we will store it in the hard disk or the SSD of the computer. Okay, so that is also instruction we will give save, like we have that save as command. So whenever we save a file, it is saved in the storage unit, and while we are working on something, that would be currently working in something, that would be in the memory only. Okay, so whenever a application is opened, it is first loaded in the memory unit. Okay, let's continue later after this in the next video.